Hello again. In this segment of 10 concepts to learn about AI, we are going to look into these 10 concepts. The concepts are: what is neural network, what is machine learning model, what does a data scientist do, and what does a machine learning engineer do, or what does an algorithm engineer do, and what does an AI engineer do. Finally, we will look into what is classification, clustering, regression, and dimensionality reduction. So without making any further delay, let's look into what is our very first question. Our very first question is, what is a neural network? So neural networks are a set of algorithms to recognize pattern in the given data, similar to a human brain. If we look into human brain, why it works, it looks the data is really understood through a variety of layers, and these layers are interconnected, and this information is processed in each layer. A certain slice of information is processed in each layer, and finally the conclusions are made. So neural networks are not exactly, but neural networks are mimicking the behavior of human brain and finally providing the conclusions. So these algorithms, which are based on neural networks, are also called deep learning algorithms. So we could also say that the deep learning algorithms are based on neural networks. An artificial neural network, or ANN, it learned to understand the patterns in the given data based on an algorithm. So algorithms has the implementation inside it, as these algorithms are used to process the data and finally making a decision. These neural networks are used for a variety of machine learning processes, and neural networks can be used to cluster the information based on the similarities in the given data. The similarities could be based on certain criteria. There could be patterns in that way, where the data is really grouped together. So neural networks can be used for unsupervised method of machine learning. We will be learning unsupervised and supervised a little later. Neural networks can also be used to classify the information based on training data, which is really given as input. Depending on the training data and the target or the label it really configured as a target, neural networks can learn the relationship between the target and the input variables, and finally produce the results. So neural networks can be used at the same way the way statistical machine learning we are really used. The difference here with neural network is the algorithms are based on the way human brain is really synthesize and process the information. The question is, what is a machine learning model? If we take a definition of machine learning model, we can say that a machine learning model is a mathematical representation of the information it learned from data. The data has a variety of inputs in it, and in some cases there is a target variable which is depend on inputs, and in some cases there is no target variable. Even in both cases, the machine learning model has the information it really learned from the given data, and finally synthesize all that information in a mathematical way, and finally compose that information in the form of model. In machine learning, the final output is the model. When a machine learning process is complete, your output is a model which represents the learning from that data, and that model is really your output, which you can apply on new data to generate predictions, or we call them a score. And then at that time, it's very important to understand how accurate your results are, and that accuracy has to be defined through how accurate the model is, or how good the model learn from the given data. And that accuracy is really being has to be calculated, and the calculation of model accuracy is a very simple process, where after model learn from data, that model is applied on a test data set where we already have what the correct results are. In that scenario, the model results are validated through the actual results, and the percentage is calculated to determine the accuracy of this model. Once that accuracy is really crosses a certain threshold where the model accuracy from above the threshold is really applicable to a business process, then model is really being deployed to start producing results which then can be consumed by a business process or can be used in a variety of ways. The application of model to a new data and generating these results is also called the scoring or inference. The third question we have in this section is, what does a data scientist do? So there are a couple of questions we have: a data scientist, machine learning engineer, AI engineer, algorithm engineer. If we look into theoretically, there are so much overlap in between these positions, but there are some dedicated work is also being considered to be the core objective of these positions, and that is what we are really trying to understand in this presentation. The objective is the objective here is to understand the core work among these different positions the person really do. So that's why we could understand that what is a real data science and what is a real machine learning engineering and what is the algorithm engineering or what is the AI engineering. So data scientists, they really mostly play with data. Their job is to work on data from from the data insertion all the way to finalizing the output of a machine learning process. So data scientists, they really work on various aspects of data. They look into data acquisition method. They might have to work on finalizing the various data acquisition processes and the combination of these processes, so they can actually merge the data into a single data set. So that's considered as a data preparation, because that final one single data set which is merged and combined into the final data set that is ready for machine learning. Once data set is ready, they really need to validate and check if the data is really ready for machine learning or it's a machine learning ready data. It means if there are impurities, there are some missing information, then they really have to understand what those are and how to really rectify them, how to remove them. So all the work is also done by a data scientist. Feature engineering and data augmentation are two very important process that is also part of data scientist work. We will be learning a lot more about these in subsequent presentation. However, feature engineering is quickly is a process where a data scientist really understand different features within the data set and try to enhance them by either adding the more information to them or taking them those features and really expanding them to even adding it so that they can produce even more rich information from that feature engineering could be done by working on that data set which is available, or they can augment the more data by bringing other relevant information depending on what those features are. A data scientist's job is also to understand which algorithms are going to be best fit for that need, or maybe just apply all the algorithms, and then finally making sure that results which they are generating are really applicable enough. They are good enough. They are applicable for that business process. Those algorithms, their implementation, which libraries they are really implementing to. This is also part of data scientist. Finally, a data scientist really generates the machine learning model. These models are the final output of a machine learning process so that it can be applied into a business process. Once model is generated, they have to really validate the model correctness and find out what its accuracy is or how accurate it for that business process. If the accuracy is not accepted or it really has to be improved, then a data scientist has to go back and understand what else they could do to improve the machine learning model accuracy so that it can be applied into a business process. So you could see there are the lots of things a data scientist really has to perform in their job to make sure that machine learning process is really generating the business value out of it. The next question we have is what does a machine learning engineer do? Okay, so machine learning engineering, which is a little different than a data scientist. A machine learning engineer is basically, at heart, is a software engineer who is really applying his own art of software engineering into a machine learning process. So machine learning, if we look into what is a machine learning process, it's an end-to-end process of working on the data and finally generating the output as a model, and then taking that model and applying into a pipeline where it can generate results. So a machine learning engineer, they basically apply the software engineer into a whole data science pipeline in a variety of ways. They can use this their software engineering learning to expedite that whole process, or maybe they can make it even much more better. A machine learning engineer also look into and say that, okay, is this the requirement of data set is really good enough for the results, or they really need to improve on a framework or on a method where they can really feed a lot more data into a machine learning process. Is the environment or the engine or the framework or that whole infrastructure is rich enough, capable enough to feed and process that data? If not, then they really need to apply the distributed data processing method and do all kinds of things what is really required to make sure that a data scientist can work on and generate effective results. A machine learning engineer will also make sure that this whole process is up and running, and they can look into this process, find where the issue could be in the infrastructure and remove them, or if there is a way to improve them, or keep applying software engineering process to make sure that machine learning process is up to the mark and it's producing great results. The next question we have is, what does an algorithm engineer do? Machine learning, we have seen, and so far we have learned, is that all about algorithms. We have algorithms. They are implemented into variety of programming languages and frameworks, as well as the libraries. So algorithm engineer job is to understand the algorithm, sometimes make sure that these algorithms are really applicable, and then implement them. This is a very important process of machine learning. Sometimes the algorithms are very data specific, because sometimes they work on certain kind of data, or they work more effectively on certain kind of data versus less effective on certain kind of data. So what an algorithm engineer can do to make algorithms more versatile, or maybe more good enough on a certain kinds of data. So they really have to look into variety of these aspects of algorithms to make sure that their applicabilities are good. They are producing a significant results as is really considered when the algorithms is really being was created. And they also need to look into that how that algorithm really work on in a given in a given scenario, whether it's infrastructure related, or whether it's input related, or it could be an output related. So they really need to look into those various aspects and understand if there are any problems, if there is a room for improvement. If there is, then either rectify the problem, isolate it, fix it, improve it. So those are a variety of things an algorithm engineer do. They are a lot more, they also need to look into the mathematical part of it, because these algorithms are all the mathematics underneath. So an algorithm engineer really has to be very, very capable enough to understand the mathematical portion of those algorithms, and has and must have ability to take those mathematical concepts and use the software to really implement them and implement in a way that these algorithms are really applicable within that framework where they are designed to work with. So there is a very important part of machine learning which these algorithms engineer really do. Our next question we have is, what does an AI engineer? If we look into AI engineer, artificial intelligence is a really very wide as is very wide in terms of definition. So the role of AI engineer becomes really very wide too. Sometimes we can say that the majority of data scientist, machine learning, as well as the algorithm engineer job, it's all became part of AI engineer job as well. So an AI engineer, they really look into a lot versatile. They really look into machine learning from a very different perspective. Like they are pretty much, I would say that they are the person who really can work and smart enough to take care of any aspect of machine learning, whether it's on-prem, cloud, and including the which chip label, whether it's a GPU specific or TPU specific, or it's a CPU specific, in which scenario it's really going to work, how it's really going to improve. So all those things are part of are various part of AI engineer. An AI engineer also look towards the continuous improvement and the development of a machine learning pipeline, whether they are looking into from an outsider perspective and see that what else can be done to improve the results here, or just developing something very different and then bringing into the pipeline. They look into what algorithms, what engines can really improve the results, or whether it's an improvement in a performance or whether improvement in the accuracy. They can also look into and say that, okay, whether the platform or infrastructure is good enough to process that size of information. So what else they could do to either create a different infrastructure which is capable enough for that requirement, or they can really find a ways to process the data in different way. So all those things they could really do. And then AI engineer will also look into a scoring or the inference, where they can really see that if the data is very large to score, is the scoring results are fast enough that a business process can pick them up. So they can also look into what the best way a scoring process can have the highest achievable performance, and look into, and they can really understand that part, and then finally come up with an improvement which could result a significant performance gain, whether it's a machine learning process or within the scoring process. Our next question is, what is classification? So classification is a machine learning technique to identify the outcome or identify the final result. If you are new to machine learning, then it's really very important information for you to know. The classification is a supervised machine learning process, which we learned later what is supervised, but here we are understanding what is a classification. And classification is a scenario where you have a variety of inputs such as x1, x2, x3, xn, and they are all generating output y, where y is really depend on all those x1s to xn. If we take this equation into an example, we can say that we can predict a person's salary such as x1, person age such as x2, person marital status like x3, person hereditary value if there is x4. Variety of information we could say, and then output y will be whether this person is going to buy house or not, yes or no. So if we have this kind of scenario, this kind of data set, and we use to classify whether a person is going to buy house or not based on given x1 to xn, we consider this method is a classification. In this example, you could see the results are only two: person will buy house or not, true or false. So we could say that this is a binary classification because here we are choosing results from either yes or no, true or false. But that is not limited to, because sometimes you may have more than two classes, maybe three classes. You really trying to predict a particular item belongs to which class, such as a flower, whether it's belong to class A or class B or class C. You might have an automobile which is belongs to a variety of classes, class A, class B, class C, class D. So if you have more than two classes to identify, then the classification method is called multi-class classification, or it's also called as a multinomial classification. So classification is a supervised machine learning method where you really try to identify the outcome or target y based on given inputs. And classification process really look into all those inputs and create a relationship between output and inputs, and finally produce a model where you can use that model to predict the outcome of the given data set on which that model was trained to. Our next question is, what is clustering? Clustering is a machine learning technique to group given data into various smaller subgroups. And this grouping is done based on the similarity found within the data set. And the clustering methods are required sometimes when you have a data set where you do not have the final outcome or the target or the label. The examples could be that you have really very large amount of log where you really do not know what kind of information you have in this log. You might have a log related with a bank transaction where millions and millions of information, these records are there, and you really want to group them in a way that certain kinds of similar information found in these logs could be grouped together and further analyzed. So clustering is a very important machine learning techniques. It's part of unsupervised machine learning process. And the examples for clustering could be recommendation. Anomaly detection is also part of clustering, where you really try to identify a certain or a group of certain information which does not belong to remaining part of information. So that's where the clustering is, and the clustering is really done by a variety of algorithms. There are several algorithms are available which could apply for a clustering process. In the clustering process, the similarity within the data set is all depend on what kind of information is really being found in the data and how the algorithm is really select a certain criteria. It's all depend on algorithm and the engine which is really being applied on the data set to really understand the group. Because if you try to apply two separate algorithms, you might see a two separate cluster of results in that process. Our next question is, what is regression? So regression is again is a part of machine learning supervised process. The difference here is that the outcome we have is really a numerical rather than a class where we saw in the classification. There is some overlap which we would not consider here, but however, for the beginners, you could understand that regression is a process where your outcome is a numeric or a real number. And the best example is suitable for this scenario would be a house price. So you have various inputs such as x1, x2, x3, or xn, where x1 is a year when the house was built, x2 is the number of rooms it has, x3 is the number of bathrooms it has, x4 is the total constructed area, and x5 is the total lot size, x6 could be the location where this house is located. So all these inputs between x1 to xn is really determining factor of the output y, which is the house, the price of your house. So when you have a data set where you have output a real number and then you have given inputs and you apply a machine learning process on it, and that process is really considered as a regression. Okay. And then in more deterministic way, you could also say that as a linear regression. And in the regression, what you are trying to do is that you are trying to determine the relationship coefficient between the dependent and independent variable by applying a certain method, and that method is what is really part of your regression algorithms which you are really using. You could use a statistical method for that. You could also use a neural network for that. So it's all depend on the algorithms, its implementation, and how it really try to understand the relationship coefficient between the dependent and independent variable. Okay, finally those coefficients are generated and then summed together to and group into in a mathematical way, which is your model, and that model is really being applied on a new data set to predict the outcome. Our next and the final question in this section is, what is dimensionality reduction? Dimensionality reduction is also part of unsupervised method, and sometimes, and we can also look into that this is somehow really closely related with clustering too. What really happens here is that we really try to look into a data set and see that is there a requirement for dimensionality reduction. So before even we try to look into, we understand what is a dimensionality reduction. And even before a dimensionality reduction, we really need to look into the concept of wide, deep, and dense data. Sometimes data sets are really very wide. They might have tens, thousands, or even hundreds of thousands of columns or features in it. Sometimes these number of features are really very overwhelming to really process on. The information would be in really very like a true, false, 0, 1. So information is really very sparse. However, these features are really very vast. Like, and then in that scenario, the objective is to compress all those number of features into a group of features where the information has a very less loss. And the dimensional reduction is a process where you can compress your data set width to a number of manageable features. So for example, if you have hundreds and 800,000 over a million features, and you can compress them into a few thousand columns or features, now your data set became much more manageable to work on, and that process is considered as a dimensionality reduction. It's an unsupervised machine learning problem. So PCA and GLRM are most popular and widely used dimensionality reduction algorithms are. We will be learning a little more about PCA and GLRM in subsequent presentation as well. So that was the end of the 10 concepts we understood in this presentation. Here is the recap. We learn about neural networks. We learn about various machine learning data scientists and these engineers, what AI engineers, what they really do in their day-to-day job. We took the supervised and unsupervised machine learning concepts in terms of their definitions, such as classification, clustering, and regression, and the dimensional reduction in this presentation. So that's it. I really appreciate your time. I understand that you have learned, you have achieved something from this presentation, and we will be carry on to learn what is in our next presentation to understand what the top 10 concepts you really need to know about AI. So once again, I thanks for your time, and I appreciate